Hello everyone, this is Anurag from DSI. Today I'm very excited to preview the EEMS plugin for BASINS. This plugin will let you make an EFDC model right from the BASINS interface. This preview today assumes that you have a basic understanding of the BASINS interface. In this demonstration, I downloaded the project file for the HUC 07090002 crawfish in Wisconsin, and this is the area near the city of Madison. This is Lake Mendota, and there are multiple rivers that are flowing into the Lake Mendota, and this is the outflow. And these green lines are the NLDAS grids. I downloaded the meteorological data for these NLDAS grids and the NVIS data, USGS NVIS data at these stations already in the WDM format. So let's get started. Click on the EEMS plugin icon and select the shapefile, in this case Lake Mendota SHP. Make sure that the UTM zone is correct here, and right now it has made grids 50 by 50 and I can change it to 40 by 30. Recalculate so that these cell size change. Remove dry. All the dry cells that are outside the shapefile get deactivated. I decide which folder I want to put my model in, and then I go to the import time series. In import time series I get a form that gives me an option of importing multiple different kinds of WDM files. First I start with flow. I can navigate to it, or the recent files show up here in this down button. Click on flow, and then it has 24 time series. I want only specific 5 time series, and I went ahead and selected it based on their location and the data that is available. So let me just check the numbers. This is 850 7910 30 7948, and I press control button so that I can select multiple time series. Click on OK. The flow input time series is CFS here. It will be converted to cubic meter per second when the EFDC model is prepared. You can have this flow from the observed data or simulated from a different model. Similarly, we want to import the meteorological data, and I use this to navigate to the recent file. Click on open, choose time series. I already went ahead and found that the closest NLDAS grid is X285Y145. So precipitation, air temperature, solar and potential evapotranspiration. Select those. Make sure to check these unit conversions. Then I also want wind data. Similarly, I select the WDM file, choose time series, and only one time series. That's it. So right now we can assign one station into our model. So this dialog box comes in that shows the unit conversions. Okay. Now we have the time series imported. We want to apply those time series to the specific locations. 850 is input, so we can apply it here. So let's call it Yahara inflow and 850. Okay. And 910, let's apply 910 is 6 mile inflow. 910. Okay. 930. Now you may have a more detailed model, and you will have to be more careful in applying these time series. Pheasant branch. that's 948 8500. Yeah, outflow. Okay, now I've assigned the time series. I have already imported the meteorological time series. All the meteorological data will be applied to all the cells. We click on model timing. Make sure the base time is 1900-01. That is used to calculate the Julian date and time for the EFDC model. And then I click on OK. Now what this plugin is doing is creating the time series for the EFDC model. And as that is done, a folder is opened that has all these files. So let's click on efdc.ee, and that will open the EEMS interface that has our model. Okay, sometimes that can take a couple of minutes. So then I click on 2DH view to see our grids and turn off the bottom elevation. These are the model grids. Turn on online background to see our grids line up with the actual online Lake Mendota shapefile. And then we have to assign the bathymetry to these grids. As you can see in my shirt, it says bathymetry, 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 and that's extremely important part of developing an hydrodynamic model. So to do that, I go to initial conditions, bathymetry, assign. Now you can download it. Depending upon your location, you may have a good data available from download or not. So in this case, we had the data available XYZ from the local sources. So I click on apply defined conditions. All these cells are modified, so they get this specific value. Click on OK, OK, click on OK. So once the bathymetry is applied, you can see the bathymetry here. This is deepest part of the lake. These are shallower parts of the lake. Now to start the model, we also want to assign an water depth or water surface elevation. In this case, we had elevation available, water surface elevation. Okay, now the elevation is applied here too, and you can quickly see it actually. So it looks like it's the same, almost same elevation in all the cells. We can turn it off. You can quickly see all the time series in external flow, external forcing data, all of these time series here. Now one thing to note is that when we were applying the time series from the BASINS interface, all of those were applied at specific cell, but the model doesn't know if it is inflow or outflow. We have to change the direction. So click on here, edit, and the Yahara outflow, click on edit, click on here, -1, multiply it. Okay. Okay, now the flow is applied here, negative, so it's going out. All of these are input flows. Want to change the timing also, because right now the model is starting on 1900-0101. I checked the availability of data, and I think the best time to start would be 41120, and I'm going to run it for 5 days. And this one, I don't think you should worry about it now, but you should look at other EEMS video to figure out what's the best time step to select and how to improve upon it. And some of it you can learn through trial and error. Some of that you can look at the guidance. So I'll click on OK here and save it. So it's full write because the time series have changed. So we would do a full write. Click on OK. It may take a couple of minutes depending upon how many time series we are saving. Okay, so it took few seconds and let's run the model now. Okay, so you just click on override because I ran the model before, and I run EFDC plus. A command line window shows up, shows that the model is running and how many domains it is using and all those kind of details. And once the model run completes in about 2-3 minutes, we'll come back and look at some of the outputs. Okay, so that took about 2-3 minutes for the model run to complete. Let's click on OK. And we'll look one of the output. This loads the model output in EE interface. And what we will do is we'll import velocities, velocity vector, and this is 1 meter per second for this length. We'll just change it to 0.1 meter per second to be able to see the velocity vectors properly. And once we run the model, that you can actually see, I can turn off the boundaries. Okay. So you can see that the water is flowing in different parts, and these are the velocities. I should probably increase this to be for it to be more visible. But as you can see, there are things happening. The water is flowing from the different cells and going out. And it's a simple hydrodynamic model. There are no other processes occurring. But this gives you a skeleton to get started with the EFDC model. And later on, you can bring all other information like the salinity, temperature, water quality, chemical fate, and transport. And I hope this plugin will reduce the gap for a hydrologic modeler to get started with the hydrodynamic model quickly. And if you have any questions, please feel free to email me. My email is below. And if you want to test out this plugin at this stage, let me know that too. Thank you so much for listening. This is Anurag, and see you in next video.